Welcome to session number 1. Today in this session we are going to learn transmission lines, that is unit 3. In that one, let me cover the topic introduction to transmission line in this particular session number 1. So in this particular session, let me cover the definition of transmission line, the types of transmission lines and their applications. What will be the learning objectives after completion of this particular session? You're going to understand the meaning of transmission lines and the types of transmission lines and its applications. The session outcomes after completion of this particular session is the concept of transmission lines that you are going to understand, and you're going to appreciate the transmission lines uses and their advantages. Let me define with the definition of transmission line. A transmission line is a two-wire cable that connects the transmitter to the antenna or the antenna to the receiver. The purpose of the transmission line is to carry radio frequency energy for a particular desired distance. Ideally, the antenna should be connected to the device, but practically it is not possible. Anyway, the antenna will be there outside your home and the device will be there inside your home. Hence, to connect between transmitter to antenna or from antenna to receiver, I must have some physical connection that is nothing but transmission lines. As I told, it's an path of carrying alternating electrical energy from source to load also. In this manner, I can define the definition of transmission lines in multiple manners. Let me go with the types of transmission lines. There are basically two types of transmission lines. One that is based on power and the second one, the frequency it carries. Namely, I'm having two broadly classifications. First one is power lines and the second one is communication lines. Let me start up with the power line. Power lines are used for transmission of large quantity of power over fixed range of frequency. That means in India we are going to use 50 Hz frequency, while in US it is 60 Hz frequency is quite common. They are used in electricity distribution from source to destination. That means in Karnataka we have source, that means power generators like in Jog Falls, Raichur thermal power plant, Kudithini thermal power plant, and so on. In order to bring the power from that place to the consumer place like Hiriur, I need to have some physical connections, that is with the help of transmission lines. Have it in mind, these power lines are majorly used for the distribution of electricity because it consists of huge power, but the frequency will be almost in a fixed range of 50 Hz. The next type of classification is communication lines. As you know, communication lines are used for transmitting the power over fixed power, that means minimal power, but the frequency range will be varied from low to high. Here there are a lot of examples of communication lines that you see in daily life like open wire, coaxial, waveguides, microstrips, fiber optics, etc. Let me see the types of transmission lines. I have taken open wire line as the first one. In this picture, you are seeing the open wire line as you see in common in villages, in towns, everywhere. This is very common. Open wire lines, I think everybody saw this one. Here, open wire lines means these are the parallel conductors open to air. Hence called open wire. That means these will not be having any insulations. Telephone lines and power transmission lines are the best examples of open wire line. Here, the initial cost is very high. The installation of the first time initial cost is very high. These lines are affected by the atmospheric conditions. That means sometimes if it rains or sometimes if it thunders or some other atmospheric conditions also it will be affected. Possibly due to shorting, because there will be a lot of flying objects like kids will be flying the kites and birds will be flying. Due to that, there will be a shorting effect also will be happening. And comparatively, these are cheaper and can be easily constructed. Since there is no insulation around the line conductors, there is no dielectric loss itself in this particular open wire lines. Fields of open wire lines are balanced. Fields means in the sense electrical and magnetic fields. They will be almost balanced in the open wire line. The only demerits what I observed in this particular open wire line is they are not suitable for operation beyond 100 megahertz. Why? Why? Because there will be an significant radiation losses. Now I move on to the second types, cables. As you all know, cables, these are underground lines which consist of hundreds of conductors and are individually insulated by one another. You can see once again, you see multiple conductors will be there. They are individually insulated so that there will not be any shorting effects. Some kinds of cables are twisted pair cables. They are combined together and placed inside the protective lead or plastic clads. Underground electrical cable consists of 2 or 3 large conductors insulated by solid dielectric so that it will avoid some shorting effects. Next, I go to coaxial cable. Coaxial, what is the meaning of coaxial? That means it consists of copper conductor surrounded by insulation, which in turn surrounded by tube-shaped conductor or solid copper conductors. Here, the outermost tube and the center conductor, they both share the same axis of curvature, hence the name coaxial. Here the name itself says coaxial. They share which the outermost and the inner center copper conductor share the same axis of curvature, hence the name coaxial cable. In the picture you can see there is one a center core is there is a metallic shield is there is one dielectric insulator I'm having, one plastic jacket is there, and also I've given the real-time coaxial cable pic also. Here the meaning itself says they will be sharing the same axis of curvature, hence the name coaxial. And here these lines are used in high voltage levels, as I told. In the previous case, they will not be used for high voltage because there will be a lot of radiation losses. Here, the coaxial cables can be used for high voltage levels. Next, I go for waveguide. So you can see the pic of waveguide. One I have chosen the real-time waveguide. The middle one is rectangular waveguide and the end one is circular waveguide. There are a lot of types of waveguides based on your applications. You can choose in the market. Here, the waveguides are used to transmit electrical waves at microwave frequency. Microwave means huge frequency, or in the sense I can say in a simple manner, electromagnetic radiation. Waveguides are typically used in electromagnetic radiations or microwave frequency. This is a specially constructed hollow metallic tube used for carrying electromagnetic waves. It is used in micro frequency. They are also preferred than any other transmission lines because they are much less noisy or much less lossy at the higher frequencies. Hence, we are going to use these waveguides as a best alternative for electromagnetic waves or microwave frequencies. I told these are hollow conducting tubes with uniform cross section. The energy is transmitted by the phenomenon of total internal reflection because since inside nothing is there, you are going to insert the energy from the inside with some critical angle. This phenomenon of total internal reflection, I'll let you know in the further classes. You can see here the types of various transmission lines in a real time I have given here. Let me go for applications of transmission lines. First one, as you know, this is mainly used for or majorly used for the transferring of energy from one circuit to another, in the sense from source to destination, or whatever the thing you can choose, or from a TV set to antenna, or from antenna set to receiver, and so on. Second one, as an impedance matching device. Impedance matching is a very essential thing to get the lossless lines or infinite lines. That also you are going to get in the upcoming classes. What do you mean by impedance matching device? What is the role of transmission lines over there to match the impedance? Next one, power and telephonic transmission. I told in the beginning itself there are two types of broad classification. One is power line based on the range of power it carries with a fixed range of frequency. Next one is telephonic or communication lines. It will be carrying huge variety range of frequency but with a minimal range of power. And in IC connections, these transmission lines also will be used in IC connections to create computer networks such as internet or ethernet. In case if you take some rooms, you need to connect some LAN or something. Without the transmission lines, you can't complete the work, I can bet assure. So let me summarize what we learned today in this particular session number 1. We went through the explanation related to transmission line. It's a physical path to connect between one source to destination or to carry the radio frequency energy for a desired distance or from source to destination. Then we went with the various types of transmission. There are numerous ways of transmission. Broadly, I've taken two category. That one is power and communication. In that communication also, we went with 4 or open wire, coaxial, waveguide, and so on. Then we went with the application of transmission lines. Without transmission lines, the world would have become very shrinking, and these possible tremendous communication would not have been taken place without the help of transmission lines. Let me go with this multiple choice question based on the transmission line unit number 1, unit number 3, or in this particular session, I chosen some multiple choice questions so that you can understand better. So that basically I'm going to ask the question and I'm going to give the options. These are all MCQs, multiple choice questions. And after asking the question and after telling these 4 options, I'm going to pause for a while. Let you students please think around and let you answer. Then I can answer and I explain the relevant answers. Let me begin with the question number 1. By which of the following methods electrical power may be transmitted from one place to another? Option number 1, underground system. Option number 2, overhead system. Option number 3, both 1 and 2. That means both underground system as well as overhead system can be used. Fourth one, none of the above. Here, the answer is both 1 and 2 because the electrical power may be transmitted both as well as underground as well as overhead. In sea or oceans, we can't able to take that overhead pattern. In villages and towns, we are going with the overhead pattern. So the answer is option number 3. Let me move on to the question number 2. Which of the following transmission line have more initial cost? Option number 1, overhead transmission. Option number 2, underground transmission. Option number 3, both have almost the same initial cost. And the fourth option is none of the above. The answer is underground transmission. Because overhead transmission that will be seen with the help of your eyes. You can do whatever you want. But underground transmission, the laying cost will be very huge. Hence, underground transmission takes a lot of initial cost than any of the things. Let me move on to question number 3. Name the cable or conductor which connects the distributor to the mains line or distributor to the consumer terminal. Answer number 1, service mains. Option number 2, distributor lines. 3, feeders. 4, none of the above. The answer is service mains. Service mains are the cables in an electric terminology. Service mains are the cables which are going to connect between distributor to the consumers. For example, in our village cable network, there will be one distributor is going to connect to the consumers with the help of service mains. Let me move on to question number 4. Transmission line insulators are made up of option number 1, porcelain, option number 2, glass, option number 3, composite polymer, fourth, any of the above. The answer is option number 4, any of the above, because insulators can be made up of porcelains, glass, composite material, or anything. Insulators are nothing but, first of all, in order to avoid shorting, in order to avoid conductance between intercables. So we are going to use insulators. They can be prepared or made up of porcelain, glass, composite polymer. Hence, the answer is option number 4, any of the above. I move on to question number 5. With respect to high power distribution, which lines are used? Option number 1, communication lines. Option number 2, power lines. 3, parallel lines. 4, waveguide. The answer is power lines because power lines are meant to carry the high power energy with a fixed range of frequency. Hence, the answer is power lines. They will be used for high power distribution like electricity from source to destination. Question number 6. Transmission lines are used in distribution of option 1, power, option 2, information, Option 3, communication. Option 4, all of the above. The answer is all of the above, because the transmission lines are used to carry the power from one station to another station, information from one source to destination, communication from one place to another place like radio frequency transmission for a desired distance. Hence, the answer is it carry all. The transmission lines are used for the distribution of both power, information as well as communication. Hence, the answer is option number 4. Question number 7. At microwave frequencies, the transmission line used is option 1, open wire, option 2, balanced two wire, option 3, twisted pair, option 4, waveguide, option 5, all of the above. The answer is waveguide. As I told, waveguides are purely meant for electromagnetic radiation. That means it will be used for high frequency transmission like microwave frequencies. Hence, the answer is waveguide. Option 4 is the answer. Let me move on to question number 8. Which of the following has same axis for outermost tube and center conductor? Option 1, coaxial cable. Option 2, waveguide. Option 3, twisted pair cable. Option 4, all of the above. The answer is coaxial cable. As in the explanation I told, what do you mean by coaxial cable? Coaxial means the axis of curvature is co to whom? To outermost tube as well as the center conductor. They are going to share the same axis of curvature. Hence the answer is coaxial cable. Option number 1 is the right answer. Let me move on to question number 9. Lines used for variable frequency components with minimal power range. Option 1, power lines. Option 2, communication lines. Option 3, both 1 and 2. Option 4, none of the above. The correct answer is option 2, communication lines. I told communication lines are preferably meant for the transmission of frequency over variable range but with a minimal power. Hence the answer is option 2, communication lines. Question number 10. Radiation losses are comparatively high in option 1, coaxial cables, option 2, waveguide, option 3, open wire, option 4, fiber optic cable. The answer is 3, option 3, that is open wire line. As you know, open wire lines does not have any insulations around that one. It will be open to atmospheric conditions. Hence, there will be an huge radiation losses in terms of heat, in terms of there will be quite factors how it may losses may occur. Hence, the answer is open wire line will be having huge radiation loss compared to all other transmission lines. Hence, open wire lines will not be used for the transmission of important communications. I hope you understand. So thank you one and all. Stay home, be safe. Thank you.